This is Chapter 8, Section 8.2, Integration by Parts. Integration by parts is uv minus v du, and it's called Green's theorem, but we're not getting into Green's theorem. What we need to see is that we are going to produce a u and a v. Once we have the u and the v, we multiply them, subtract this integral, which is the integral of the v du. Let's see how that works. The main idea in integration by parts is that we want to decrease the power of a function down to 0. And usually we must pick. There are two functions. Here we have the two functions. It's an integral that has a function of x multiplied by a g of x dx. So you can see that one is not anymore the derivative of the other. If they were, this would be u du, but that's not the case. There will be two distinctive functions here. So our goal is to see if there is a power, and that's going to be u, because the derivative always knocks down the power. So we're going to go through many loops until the power of x drops down to nothing. Therefore, this function disappears, okay? But we must also be careful because we need to pick the easy derivative to be u. If you pick the wrong of the two to be u, you're going to feel it, because as you go forward, it becomes more complicated instead of becoming easier. Here's example 1 from page 524. Well, what do we have here? Function x and function e. There are two functions, f and g. So we're going to pick x to be u, because if x is u, the gu is dx, very easy derivative. The e to dx is considered more complicated than the plane x. That is going to be dv. So note that the names tell something. It tells us that one is a function, but the other function is going actually to be treated as a derivative. That's why I put it under, and we go up, because we're going to integrate this piece. Therefore, we're moving up. So I like to put the dv under, and then I go up. Well, what is the v? Well, the v is the integral of the dv. So what happens if I integrate the dv? Well, I get the v. So we have to find the v each time. Now we set it up. uv minus v du. Here's the u, here's the v. Put them here. We'll never touch this piece again. This is already part of the solution. We don't need to do anything else to u times v. Minus, but now we need work here, because integral of v du. Here's the v and the gu, which is simply dx. So because we write v as a function with x, then I pick the gx. Therefore, uv minus v du. v du. So now I have this piece as answer, but I need to find this integral. Well, I copy this piece, and now I must integrate e to dx, which is simply e to dx with a minus sign. Now I have repeating terms, so I factor out the repeating parts, get out e to dx, and I have an x left, a minus a number 1 plus c. So this is the integral. The next example is a very intriguing function, because there's a lot of mistakes and confusion every time we ask somebody to integrate log natural of x dx. Well, note that sometimes students jump so quickly to the conclusion that the answer is 1 over x. Well, that's totally wrong. Wrong. It's not that. 1 over x is the derivative of log natural of x, but we are going up. So what is above log natural of x? Well, that's what we're doing now. How can we integrate log natural of x? Well, almost 100% of the times, if you see log natural of x, that's u. You don't need to think for too long. If this piece is u, then the other piece has to be dv, dv. Okay? Therefore, u is log natural of x. The derivative is easy, 1 over x dx. So the dv is going to be dx. dv is dx. V is the integral of dv. What happens if I integrate dv? Well, if I integrate dv, I'm integrating the derivative. Therefore, I'm getting the function. So the integral of dv is the same as the integral of dx, which gives me x, right? You integrate the derivative, you get the function x. Okay? So now we set up uv. Here's the u. Here's the v. X log natural of x are going here. Minus v du. Note that the v is the x. Here's the v. Here's the v. What is du? Take a look. 1 over x dx. Now you note that this piece here is a nice piece because x times 1 over x equals x over x, which equals 1, which equals the integral of 1 dx, which is simply dx, because I don't need to put that number 1 there. So I copy this piece minus integral of dx. Well, if I integrate dx, I'm integrating the derivative, I'm getting x. And the answer, therefore, to the integral of log natural of x dx is x log natural of x minus x plus c. Now, I have a repeating part, which is this x and this x. I can factor out the repeating parts, and I get log natural of x minus 1 plus c. Problem number 16, page 529, I have this function, 5x divided by e to the 2x dx. I'm going to rewrite it so I make the integration easier. I get this 5 out. Here it is. I keep the x where it was, and I move this guy up there, and therefore the plus 2x comes up as minus 2x. Now, we have done a case like this. The simple derivative is x, so u is x, du is dx, and therefore the other piece has to be dv. Note that you have to put this dx here. A lot of people don't, and you lose grade. Okay, dv equals 2 power minus 2x dx. If I integrate this, don't forget that I'm getting this half here. A lot of people forget this half. This half is the reciprocal of the minus 2, okay, which is the derivative of that power. So the v is this piece. So now ux, v, this piece. So I'm going to get uv, here is uv, I put the minus half earlier so it looks better, minus, here's a minus, minus with this minus from the v becomes this plus. And now I have half e to the x. Well, we know that this is going to integrate as minus half e to the minus 2x plus c. Now, I already have another minus half there. With this, I have a quarter. This is a plus and this a minus, so I get this minus. So I'm getting, for this entire thing here, I'm getting this piece. I already had that. It's time to factor out. So the repeating numbers, you factor out the smallest, not the biggest. A lot of people think it's the biggest. Well, remember algebra 2. You factor out the smallest. So a quarter is smaller than half. So I factor out a quarter. And then I have this repeating part. I factor out the repeating part. So I'm factoring out minus a quarter e to the minus 2x. Now, what do I have left here? Well, I have left the x, which is here. So why do I get a number 2 here? Well, it's because if I take 2 quarters, I get the original half. That's why I have this number 2. In other words, this times this gives my original half. So be careful when you write this inside if you have a fraction, okay? Don't forget your algebra here. It's 2 quarters makes the half that I had, plus 1. Well, 1 is because this entire piece has been factored out. So for this part here, I actually have number 1 because the entire thing is out, plus c, and this is the answer. Now, integration by part is by far the most important integral. In higher level math, such as advanced engineering, advanced mathematics, advanced statistics, it's parts that you use. So please make sure you go to your book and work on problems numbers 5 all the way to number 50. And practice does it, and practice will allow you to solve problems quicker and with fewer and fewer and fewer mistakes. Good luck.